So this time we're going to be talking less about models and more about the actual phenomenon of translation itself. And so translation, I mean, I barely need to introduce what translation is. I'm sure everybody knows, but basically it's the conversion of content in one language into content in another language for the purpose of making that content understandable to somebody who doesn't know the original language, of course. And that can be anything from, translating novels like Harry Potter to, any other variety of translation that happens. And this time I'm going to be talking about how this translation happens, a little bit about machine translation, and then also about machine translation data sources and MT evaluation. So there's actually two types of conversion of language between different languages. There are two main types. One is translation, another is interpretation. And translation is basically the conversion of written word from one language to another. And interpretation is conversion of spoken language from one language to another. And they're very different in the requirements for them, also how people work and the type of people who work in these areas. So translation in general is usually less time constrained. You may still have a deadline for when your translation results are required, but usually it's on the order of, like a day. Somebody gives you a translated document and they say, I want this back in a day. Whereas an interpreter may interpret while the content is being produced. While I'm talking, an interpreter may be interpreting my speech into another language. That's simultaneous interpretation. You can also do consecutive interpretation, which is basically like I speak for a while, then the interpreter speaks for a while, I speak for a while, interpreter speaks for a while. Translators, a high degree of accuracy and very fluent natural output is necessary. And partially because of this, translators may translate all kinds of things, but very often they specialize in a single area. Like I'm a medical translator, or I'm a patent translator, or something like that. On the other hand, interpreters may specialize in an area, but more commonly they're generalists who can interpret lots of different things. I actually worked as an interpreter and translator for about 1.5 years, and I did both of them because I was kind of in a position that was a little bit less specialized. I worked at a local government in Japan. They additionally had a single translator and a single interpreter. And it's very interesting because personalities are also very different. Translators are often somewhat introverted. They like working on their own. They really like being precise, whereas interpreters have to be really good at talking because they spend their whole day talking. They tend to be very extroverted, like talking to people in general, not just interpreting between languages. So both of these jobs are very hard. I found interpretation harder because of the time pressure and the constraints. And it's not, you can't get 100% accuracy in a situation where you're expected to interpret things. So you just need to do as well as you can. How much translation is done? The language services market is $56.1 billion. That's a lot of dollars. And there's 640,000 translators worldwide. About 75% of them are working freelance, and the other ones are employed by a specific organization. Interestingly, Europe owns 49% of the market share. So 49% of the people, about half the people, are working in Europe. And one interesting thing is you might think that as machine translation technology is getting better, that was, threatening translators and their jobs and, reducing the value of the industry. Actually, the contrary is true. More translation is being done than ever, both machine translation and human translation, and the value of the industry is doing nothing but improving. So in a way, more language is being translated now than ever. Another thing is that the translation industry is becoming more technological. So 88% of full-time translators use some variety of computer-aided translation, which means that they're using machine translation. They're using something like translation memory that allows you to look up other related translations. The most common tool is something called Trados, and basically it has translation memory, it has integrated MT, it has terminology management software, other things like this, and a lot of translation agencies require that you use Trados in order to be able to work with them. There's also other ones that I'm less familiar with, but basically, if you have this idea of like human translators versus machine translators, in reality, it's not the case anymore. It's now a hybrid of humans and machines working together. Some people like this, some people don't like this. Some people would prefer not to be told what to translate by their translation memory, but you know, in order to improve efficiency, people now have to do this as part of their life. Any questions about that? Yeah.
Why is that happening? Are people not trusting machines enough, or is that?
So the reason why some people don't like translation, computer-aided translation, is I think they feel it stifles their creativity, or it because they can do it more efficiently. Now the requirement is that they do it more efficiently, so they have less time to sit and think about the perfect translation and just have to crank out content, basically. So I think those are the main reasons why people are like resistant to technology, but nonetheless, 88% of people are using it. So even if they don't like it, they're using it because they, you know, have to in order to keep up with the amount they're expected to produce or something. So a lot of people do like it, so it's not everybody. Yeah.
If we were to understand the difference between translation and interpretation from modeling point of view, so data that is different for both the types of models, or is there some other difference?
So from the modeling type of view, the biggest difference is whether speech is your input or text is your input. Another big difference is interpretation. Sometimes you're expected to do it in real time. So that's called simultaneous translation. So you need to create the output before you've like read the whole document, essentially. So, that's a very interesting topic. It might be a topic that some people in this class want to work on. If you like the speech, you like the translation. It's a very hot topic right now. Cool. So now, what about difficulty in translation? Why is this hard? So this is an example. I cannot read this example. I inherited it from someone else, but it's basically an old Chinese poem. And the reason why it's difficult to translate in general is because there's divergences in lexical information, so words in structure. So this is an alignment of the glosses in Chinese with the words in English. If you don't know what a gloss is, it's basically a word-by-word translation in the same order as the original sentence. So this is what it looked like in Chinese. Unfortunately, I don't have the Chinese characters above for all the Chinese speakers, but you can kind of see what it looks like. And basically, if you look at the Chinese, it's like Dayu alone on bed top think Bao Chai, which gets translated into as she lay there alone, Dayu's thoughts turned to Bao Chai. And you can see that the ordering is different between the two. Also, you know, some words exist in the Chinese but don't exist in the English, even more so in the next sentence. So you need to get the words right. You need to get the words in the right order. And this is non-trivial when, you know, the translations are different between the two languages. Here's another example from German, which might be a little bit easier to parse if you're not a Chinese speaker. So if you have here, you can see the gray gloss on top, which is in the city exploded a car bomb. And the kind of canonical English translation that's listed here is a car bomb exploded downtown. So you can see that the word order changed. Also in German, some things like car bomb is a single word here. It's multiple words here. There's also a phenomenon called translationese. And what translationese is it's not exactly natural in the language you're translating into, but it's a translation that is direct and kind of maintains the original characteristics of the original language. there's actually a fair amount of computational study of translationese, seeing how like which language you're translating from affects the output. And you can even take translationese, cluster it together, and you get a very nice reproduction of the language family tree that the languages came from. So basically the effects on translationese very strongly inherit the effects of the original language, and even, you know, are similar between similar languages, etc. So you can see there's a very clear effect. And here in the inner city, there exploded a car bomb would be a very like literal translation that you can understand in English, but it's also not natural English. It's not like what an English speaker would produce. Another issue is not just structure, but also lexical ambiguities. So this is an example from Jurafsky and Martin's speech and language processing, where basically you have leg and foot and paw, and how they are translated in different ways based on whether it's an animal leg, a leg of a journey, a leg of a human, a leg of a chair, a bird foot, or a human foot, et cetera, et cetera. Okay. I also thought I had another example, but maybe it's missing. Okay. So basically, in order to handle all of these things, you'll have to handle, you know, syntactic differences, lexical differences, how idiomatic the output is. So, you know, there's lots of issues here. And then if you start talking about literary translation, it becomes even harder, right? You know, you want to translate a poem or something like this, as we had in the assignment for the discussion today. And suddenly you need to think about rhyming, you need to think about like beauty of the expressions that you're using. So lots of depth in doing translation. Any questions there before I talk about MT quickly? Yeah.
Is there any criteria which defines what translation is?
So the criteria that I would use to define translationese, there might be a different formal definition, but I think this is basically right, is it is language that only occurs because you're translating from another language and would not normally be, you know, how a native speaker would express the same content in that language. So it's kind of like structural or lexical influences of the original language on the produced language.
Not a direct lexical translation.
It doesn't need to be. Like the effect of translation on the output could be very subtle. And often for a good translator, it is very subtle, but it's still like there. I have no confidence. I'm a native speaker of English. I'm very good at Japanese, but I have no confidence that I could produce English that sounds like my natural English when I'm translating from Japanese, for example. Any other things? Okay, cool. On to machine translation. So machine translation, I checked, is a $3 billion market. Actually, I should mention that some of the statistics I got here are from this very, very nice blog of the translation industry in 2021. If you didn't look at this on the page, I would definitely take a look. It summarizes a whole bunch of statistics and was insightful to me as well. These statistics are also from there, which is machine translation is a $3 billion market now. So it has about 5% of the market share of the language services industry overall. The top providers of it are Google, Amazon, and DeepL. So Google, I think a lot of people know. Amazon and AWS Web Services provide translation for a lot of businesses, for example. And DeepL is a startup that many people might have heard of, but it has actually very good translation accuracy. They haven't revealed all of their secrets, but one of the things is that they use like cleaner training data. They have good training data cleaning strategies, and they also consider context in a better way than other things like Google do. Another thing about machine translation is these are the markets that machine translation is used in. You can see that the most common ones are healthcare, automotive, and military and defense markets, but it's kind of spread out pretty widely, including e-commerce and other things like that. There's a very interesting paper that examined the effect of translation on e-commerce that I don't have in the references, but I can share, which demonstrated that when eBay, I believe, introduced automatic translation between Spanish and English, the number of sales from Latin America to the US basically started increasing immediately after that. So you can see also that, MT has real world consequences, impact, etc. So these are the list. This is maybe a slightly old list of languages supported by Google Translate. It's pretty impressive, at least 100 languages. Maybe it's nearing 200 now. One thing that I like to mention to people whenever you look at this list is just because there's 100 languages on this list doesn't mean that MT is equally good for all of the languages on this list. It may be obvious if you think about it a little bit, but sometimes you think, well, it's on this list. Google released a product for it. It must work. That's definitely not the case. If you try to use it to understand articles, you'll see a very big difference. There are some reports that MT is now at the level of human professionals in some areas, like, for example, news translation between very high resource languages like Chinese and English. I didn't believe this at first when Microsoft first put out an article that said this, essentially. And I went in and analyzed their data, looked at their data, and actually their outputs are quite good. And human translator outputs are not perfect either. So for example, let's say you hire a human translator on a freelancing site and tell them, I want you to translate these news articles because I would like to create training data for a machine translation system. If you do that, the translator will say, sure, I want your money. I want your money. I'll be happy to do that, but they're not going to be super motivated. And if you say, instead to the translator, say that I'm going to be asking you to translate these news articles for CNN and or the New York Times, and 100,000 people are going to read your article, you're pretty sure they're going to do a good job, right? They're not going to make a mistake. So which human translator you're comparing people to also makes a big difference in these outputs. And not even just which human translator, but how motivated that human translator is. So I have a feeling that MT systems in high resource languages are almost as good as moderately motivated, good professional human translators, but they're not as good as somebody who's translating for the New York Times for 100,000 people, for example. Oh yeah, so sorry, here are my other examples. This is from Google Translate. I basically put in the first, sorry, I had animation on this until I had to switch computers, but I put in the first sentence from the Wikipedia article on translation and output it through Google Translate, which said, translation refers to the act of replacing what is expressed in the form of A in a language with the form of B that corresponds to that meaning. Specifically in natural language, it refers to the act of converting a sentence in the source language into a sentence in another target language. I did a few small edits here. The red stuff are my edits that I think would make it a little bit better, but it's pretty good. Here's another example of machine translation. I entered a lexically ambiguous word, kodo, in Japanese, which can be either code, cord, or cord, depending on the context. And it does a pretty good job at disambiguating electrical cord, code for the program, chord for on the score. But if I wrote, as a musician, I am good at reading chords, it made a mistake with that. In Java, I wrote a chord that displays the chord of a guitar. That should have been code up here, so you can see that it is not perfect at doing this as well. So translation is hard. Even good things like Google Translate are not perfect, but they're pretty good in high resource languages anyway. So why do these work? I'm going to be talking more about translation models next class, but basically I'd like to go through a little bit of history into how these were conceptualized. And from 1968, there's this famous thing called the Vauquois triangle. And basically what it is saying is there's multiple ways to do translation. You can go from words directly to words, so you can basically replace words by words. You can go up to the syntactic structure of languages and then generate from the syntactic structure. You can go up to semantics in the language, convert the semantics between the languages and go down. And you can go up to something called an interlingua, which is like universal semantics for all languages. So what does this look like? Direct transfer looks like word by word translation. So you would just be translating directly from words to words. Syntactic transfer would be like analyzing the syntax of the sentence and then using that to translate. You could also generate syntax of the target sentence or translate from syntax of the source sentence to the target sentence and generate the output. You could also have something like semantics, which is a logical form, which basically says, well, something was detonated. What was detonated? It was a bomb, like a car bomb. It was detonated downtown, and that was in the past tense. And then you generate the output based on that. You could do other things. And then there's also an interlingua, which basically says nothing about the individual languages and instead is completely in kind of a logical form. So each of these methods has their own advantages and disadvantages. The advantage of going directly is like, let's say we have a language like Spanish and Italian, which are very, very similar in words and structure and other things like this. There you could basically do a word-by-word translation and do a pretty good job. However, if you have very different languages, you're going to have a lot of trouble. You need to have basically a very powerful model to allow you to do this. Before neural networks, we didn't have any model that really did this very convincingly well. So neural models now, you can kind of view them as models that map word by word. They take in a whole bunch of words, they generate a whole bunch of words. But you can also view them maybe as an interlingua-based model where they're taking in words and they're generating hidden vectors that correspond to the meaning of all of those words. And then they're generating from that like interlingua between the languages. So where exactly we lie now on this Vauquois triangle is kind of, unclear, but, it's kind of an interesting question as well. And, maybe considering syntax or other things like that would help us generalize better in low resource languages, for example. Cool. I realize I have a lot of slides left, and I don't want to take all of the time. So maybe I'll just go through the data part and leave the evaluation part till next time. But are there any questions so far? Okay, cool. So I'd like to talk a little bit about data because data is very important for training our MT models. And so basically all models, including, like Google Translate, Amazon DeepL, any of the things that people are using are using machine learning based methods. And basically the way they work is they're trained from parallel data sources, where you have one language and then another language, one language and then another language. This is an example that you can actually do yourself if you're like interested in trying a puzzle, which is basically like take this parallel corpus and then try to translate the sentence at the bottom yourself. And you'll see that you need to like form associations between words. You need to understand about what the syntax of the language looks like, but it's definitely possible from this this small parallel corpus. Yeah. No, I think these are made up. Yeah, I'm pretty sure. So where can we get Parallelcorpora? Basically, it's anywhere that translators are doing lots of translation. This is an example from the United Nations from a few days ago. And you can see that this is translated into, 3 languages here. It's actually 6 languages, I believe, is the official languages of the UN. Another good source that we love using for like very low resource languages is the Bible, because the Bible is translated into more languages than any other text, as far as I know. You can also get books, of course, or other things. This is Harry Potter in English and Chinese. And when you go to a restaurant, if you're not Chinese, you can go to your favorite Chinese restaurant. If you're Chinese, you can go to your favorite Indian restaurant. I don't know, something else. And get the menu, and that's a very good parallel corpus for you to try your own learning skills on. You can also harvest data from the web, like you can harvest data from microblogs, Twitter, social media, other things like this. So this can give you, more informal language, and that's why, Google doesn't completely fall over when it tries to translate Twitter, for example. So. And the canonical place to get data for any of these models now is this place called Opus. And what Opus does is it collects a whole bunch of open parallel corpora in many, many different languages, language pairs, and across many domains. So if you want to train models, this is your best place to get it. So to leave some time for the discussion, I think I'll move the evaluation part to tomorrow. But are there any questions about the stuff we talked about so far?